Greetings and welcome, friends. Mr. Waddy here. We were talking about graphing absolute value functions, which are just amazing. The absolute value with a V, these graphs end up having a V shape to them, which is, I guess, completely just arbitrary. That is not why it was called value. And yeah. Because, we don't name our functions off of the shape of the graph. Unless we're talking about conic sections, I suppose. And we have parabolas. Circles, ellipses. All right. Maybe I'm wrong. But either way, I digress. So we've talked about graphing absolute value functions from the perspective of transformations, where you kind of think about it like shift up and to the right and stretch it and smoosh it. But here we have the vertex form of an absolute value function, where if I have a function in this form, the A will equal my slopes, so to speak, all right? And then the H and the K will represent my vertex, all right? So H comma K will be my starting point, which might not be on the y-axis, and we're cool with that. Especially next chapter, once I do point-slope form, you'll be even cooler with it. But you saw this the other day, and so if I have a absolute value of x minus h plus k on the outside, it is in vertex form, and we can then quickly graph that, kind of like when we had slope-intercept form. So we'll think about this a couple different ways. For example 4. So let's first think about this in terms of the slopes. All right, what is the value of A for this equation up here? What's the value of A? What's the number in front of the absolute value? Anybody? What is the A? What's the number in front of the absolute value for this equation? I think, all right. Might be a shy Monday morning, kind of lonely here, friends on the internet. A would be the -2, all right? Let's see, let's figure out the H and the K. So H, it's always in the form minus H. H is the number inside the absolute value. So in this case, if this is minus H, H would have not been the -1. H would have been the positive one that was being subtracted. And then let's see, what's the value of the K here? That would be the +3, all right? And the K is the sign of the number that's being added or subtracted on the outside of the absolute value. So that means with H and K, I can think of my vertex as being 1, 3. All right? So, question? Excellent. Because H is always the opposite of that value. All right? It's just a weird thing. Like, see how this is a minus sign here and this is a plus sign? So H would have been the number that was subtracted. So H would have just been the 1. Yeah, so it's kind of weird. And if this was a +1, then H would have had to be negative. Whatever number is there, H is the opposite. So let's graph this using our vertex and my quote-unquote slopes. So my vertex is 1, 3, so over 1, up 3, vertex for you and me. And there we go. There's my vertex. And let's move by my slopes. All right, so -2 over 1. So from here, watch this. I'm going to go down 2 and over 1. Here's another point on my absolute value graph. Down 2 and over 1, down 2 and over 1. And now if this is the vertex, I can also have a slope of down 2 and backwards 1, and down 2 and backwards 1. Look at this like Minecraft Christmas tree that I'm drawing here. This is really lovely. Coniferous tree. And so if I want to, let's see, there we go. There's my straight edge. And now I can draw the absolute value graph, thinking about it in terms of its vertex and its slopes. All right, so that's the way that I just kind of made up, showed you how to do vertex form and slopes. And the slopes worked because I was going right down to and over 1. And in this case, because an absolute value graph is a mirror image of itself across the vertical line that passes through the vertex, that over 1 could also have been backwards 1. Right? So that's not that bad. Not that bad. Let's see, now it says describe the transformations from the graph of f of x equals abs x. So this first way that I just showed you was using vertex form. All right, here's a second way of thinking about this in terms of transformations from f of x equals abs x. All right, so let's see. Let's see if we end up with the same graph if I think about it in terms of transformations. So let's see, the parent function is the regular yellow V, right? It doesn't have to be yellow for it to be the parent function, but that's just been the color that I've consistently been choosing. All right, so let's look at what happened. So first thing, in terms of order of operations, the first thing that happened to this was the -1. So it was a horizontal shift. And this is a shift right 1 unit, right 1. Even though that's a minus sign, it's shifting towards the positive x, which is weird. It's the opposite. Okay, so for this yellow graph, this point it would have been shifted over, this point would have been shifted over, this point would have been shifted over, as well as these points, right? Horizontal shift. So that's the first thing, and we're gonna draw a series of transformations and end up, hopefully, we'll end up on that green graph if I'm right. Oh, here you go. There you are. So there's my orange graph. Now, according to order of operations, so the first thing, oh dear, all right, cut it out, I know. The first thing that I've got was subtracting 1. The second thing, after absolute value is taken, is being multiplied by -2. So the second part is vertical stretch by 2. And we'll flip it at the same time because it was negative. All right, which I guess I should say is a reflection over x-axis. All right, and the reason I'm flipping it is because this minus sign here, all right, is what's influencing that flip. So for my orange graph, I'm going to flip it, double it, and flip it. All right, 0 doubled is still 0, and -0 is still 0. All right, here's this point on the original graph, 1 unit high. Double that is 2 high, and then flip it. Okay, this point is 2 units high. Double that is now going to be 4 high, and flip it. So down at -4 for that point. Let's see, let's do one more. Here's 3 high on my orange graph. Doubling that is at 6, but then flip it, it's -6. And then I can mirror these points over here as well. Because it's a V, it's gonna be symmetric over its vertex's vertical line. I've got to work on my jingles, I'm sorry. They're not the best. All right, so that's what happens, but I'm still not done. Hopefully I'm gonna get this to be the green graph. I've got one more transformation. I'll do purple for this. The last thing that happens, so I subtracted 1, then I multiplied by -2. The last thing that happens is this +3. What does the +3 on the outside do to a graph? It's going to be not a horizontal shift, but a vertical shift. up 3. And let's look at this. Ready? Take this blue point, shift it up 3, da 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 da, and right here, da 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 da, and this one up 3, da 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 da. Right? This is amazing. Like Link is going crazy with all of this celebratory music as I'm landing on all these points. And da 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 da. We've solved the mystery, friends. And if I shift it up 3, I do in fact, through a series of technically, oh man, that was a miss. Technically, I did 3 transformations, but I still got the same graph. Now, I think you guys would probably agree that transformations was a lot more drawing and thinking than just thinking about this in terms of slopes and vertex. Right. But it does give me the same thing. So hopefully that gives you some confidence in this as a method, is what I'm thinking. Okay. And we've already graphed G for this problem. All right. So that was thinking about it in terms of transformations, as well as thinking about it in terms of this vertex form. Let's do one more just in vertex form. All right. Are you guys cool with that? You cool with that? If we do one more in vertex form, I just feel like, you can't just, sometimes you can't just learn everything in one example. That's what I think. Maybe I'm wrong. Let's see. Here's one of my own made up examples. Look at how clever I am. Maybe not at all. Yeah, using my SAD, Google Docs, equation editor. Yeah, Google's got to pick up their A game. I was pumped, by the way. This is probably old news to our internet friends, but Google finally added columns to their Google Docs this month or last month. Man, finally. Like, seriously, Microsoft Word was like just completely past you on that for so long. All right, so guys, let's think about this graph using vertex form. All right, let's do this one quick. This will be a quick one. I need to know A, I need to know H, I need to know K. Can anyone identify those 3 things on this equation? I'm going to sip my coffee and wait while you guys think about it. So, yeah, that one, sorry, isn't on your, this was just like a late add-in. So just visually follow along. Don't even write this one down. A, H, and K. What's the A? What number is in front of my absolute value? Yeah, the 1/3. What's the H? Now, H is going to trick you. I bet I can stump all of you guys. Oh, with the save! Wow! Man, I did not even trick you. What? Oh. Yeah, you got that. You figured, man, I swore I was going to trick you guys. But no, it's the opposite. And K is -3. K stays the same. So my vertex is going to be at -1, -3. Watch how quick I can graph this. And you guys aren't even writing it. So -1, -3, left 1, down 3. Bam. What's my slopes at? My slopes are 1/3. So that means I'm going to go up 1 and over 3. And up 1 and over 3. And up 1 and over 3. And it's a vertex, so I can also go, it's a absolute value graph, so I can also go up 1 and backwards 3. Up 1 and backwards 3. And I've got way more points than I need, but I've just got an abundance of these points here. They're amazing. And then I can draw my V, and it's going to have a vertical smoosh, right? Just like so. So much better than making a table of values. If we can just visualize what the graph looks like based on its equation. Yeah, good stuff. Bam, look at that. We're done. We're done. So in terms of transformations, just verbally, it was shifted to the left 1 unit. It was vertically smushed by a factor of 1/3. And then it was shifted down 3 units. When I think of transformations, and I have multiple transformations that occur, I have to think of them in terms of order of operations. Order of operations. Let me do this one last trick problem. This one you guys do have. This is I think you do anyway. Maybe I'm wrong. -1, -3. I went left 1 and down 3. The -1 already accounted for the oppositeness. Yeah, so this was to the left, but we already handled the oppositeness when we wrote the -1. Yeah, so left 1, down 3. Mm-hmm. Yeah. In terms of if I'm thinking about shifts, like, so for this one, this was a -1. I could have thought of it as a +1 for the x coordinate of the vertex, and I also can think of it as a horizontal shift to the right 1 unit. And so you can see my orange graph was right 1 unit. Yeah, so once I've opposited it once, like, I don't want to keep oppositing it because that won't be helpful. Let's see, I don't know, do you guys have question 7 on your pages? Maybe you don't. I think you do, but I might be wrong. Now this one I actually can't think about in terms of vertex form. All right, we're going to graph this graph using transformations. Yeah, maybe you don't have this one. My apologies. Just follow along. This one will be interesting. So let's see. For my parent function, okay, f of x. I haven't made that mistake in a while. It's supposed to be yellow. There we go. For my parent function, it's the classic yellow V. Something like that. So in terms of transformations, what is the first thing in like PEMDAS style that happens to the x? All right, multiplication happens before addition, even though both of these are inside of this grouping symbol. So this one, step 1, it's being multiplied by -1/2 before it was being added by 2. Notice this is actually on the inside of the absolute value. It means it's going to be a horizontal transformation. That's going to be interesting for us. So let's see, absolute value, -1/2 x. So when a horizontal transformation is occurring, let's see, can I do this with my pen tool? I did. If I'm multiplying inside the absolute value by a number, when the number is bigger than 1, it's a horizontal smoosh. Once again, the opposite of what I would have predicted. I thought multiplying by 2 would have made it wider horizontally, but no, it made it skinnier horizontally. And if I multiply by a number less than 1, it's a horizontal stretch. So in this case, my B number there, so to speak, is -1/2. 1/2 is less than 1 in the sense of it being a fraction, a 0 to 1. So this is actually going to be a horizontal stretch by a factor of 2. It's the opposite, a reciprocal of that. All right. So let's do that first. So horizontal stretch by 2. 0 multiplied by 2 is still 0. 1 multiplied by 2 horizontally stretched is 2. 2 multiplied by 2 is now 4. 3 multiplied by 2 is now 6. Oh, there we go. Right, 4 multiplied by 2 is now 8. And so this was a horizontal, nope, there we go, and there we go, stretch. All right, so there's my first transformation on it. Now this is interesting. It's a negative number. there. So I need to reflect it over, it's the negative is happening to the x, so it's a horizontal. All right, it's going to be a horizontal reflection. It's reflected over the y-axis. But guys, check about this. Check out these. It is, as a reflection, going to land. If I reflect this point over the y-axis, where does it go? It lands over here. If I reflect this point over the y-axis, where does it go? It's over here. If I reflect this point over the y-axis, it lands over here. If I reflect this one over the y-axis, it lands over there. It just got like mirrored onto itself. This reflection is going to like not change anything. Isn't that weird? I think that's kind of weird. That intrigues me. Does that, no? Maybe you guys, but there you go. The reflection did nothing. All right, let's get another point in here. Purple, adding 2. In terms of transformations, adding 2 on the inside is going to do the opposite of what we expect. It's a horizontal shift. Which direction? Which way? Which way? To the left. Man, I'm not going to sing the song. I don't even know what that song is about. All I know is that everything you own is to the left. So we shift it to the left 2 units. This one 2 units. This one 2 units. All units. That's a Halo Wars reference right there. All units. That's like, I think you hit like the left trigger and it would just select all units. And the guy would just say all units all the time. It was amazing. Man, I've got to make that like my ringtone or something. All right, so there we go. That's a horizontal shift to the left. It's in the opposite direction that I would have expected, but that's fine. We're fine with that. And one more transformation, friends. I'll use, man, I'm running out of colors here. Green. Green is good. What does the +1 on the outside do? Come on. Work with me, friends. +1 on the outside. It's going to shift it, but which way? +1 on the outside is it's going to affect everything after the function has been done. That's a vertical transformation. Is it going to shift up or down? Up. In this case, it's the same direction that you would have expected. So this is a vertical shift up 1 unit. So take my purple graph up 1, 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 everybody up 1, having fun. And yeah, look at this. This is amazing. And my green graph is my final graph. Hey, look, it's actually got overlap with that blue graph for part of it. Not all of it, though. And there's the final graph. Now, I just thought of something interesting. Where is the vertex of my green graph? I'm modifying this question, making it more interesting. Where is the vertex? Let's write the vertex form of the graph. All right, so to figure that out, I need to know the slopes. I need to know A, and I need to know my H and my K. Where is the vertex? That's left 2, up 1. So H is -2, K is +1. What does the slope appear to be? From here to that, I'm going up 1 over 1, up 1 over 1, up. Sorry, I lied. I'm saying the words that are not the thing that I'm doing. Up 1 over 2, up 1 over 2. So the slope is 1/2. So if I wanted to write this in the form y equals a abs x minus h close abs plus k, what would that look like? That would be y equals 1/2 absolute value x minus a -2 is +2 plus 1. And the reason I wanted us to think about that is because what if I tried to convert, so 1/2 x plus 2, oh dear, I went up too far. Here it is. Yeah, it turns out I could have, this'll be a question for us like later on in the course, but I could have actually undistributed out a 1/2 here. But I'll let that mystery sit for now. Well, thanks for watching, internet friends. Hope you have a great day.